Okay, so the next thing that we have to look at, and probably this will be the final video that we do for tonight, is looking at the brain itself. And what we're going to focus on tonight is looking at the hindbrain and the midbrain. So let us begin. So the brain can be divided into three major regions: the hindbrain, the midbrain, and the forebrain. As you can see, these three regions are clearly differentiated in the human embryo at 3 weeks of age. So if you look at the relative size of these regions and see how it changes in later development, we could do that by looking at the relative size at 3 weeks, 7 weeks, 11 weeks, and birth. At 3 weeks, 7 weeks, 11 weeks, and birth. By birth, the regions are not easily distinguished because the forebrain comes to dominate the other two regions in size. Nonetheless, all three regions contain important structures that regulate essential functions. The principal structures found in each brain region are listed in this organizational chart. So what we're going to do now is we're going to look at where some of these structures are located and what their principal functions are. So this photo shows the human brain from above, with the longitudinal fissure running down the middle, separating the right and the left hemisphere. The structures we want to look at lie deep within the brain. To see them, we would have to pull apart the right and left halves of the brain at the longitudinal fissure as shown in this drawing here. To get an even better view, let's rotate the brain to reveal a cross-section of the brain sliced down the middle. This photo shows an actual human brain and how it looks from this angle. The diagram highlights the three major regions of the brain: the hindbrain, the midbrain, and the forebrain. So let's take a look at each one of these. So the forebrain would be here. The hindbrain would be down here. So the structures in the hindbrain can be found easily in relationship to the brainstem. This area right here in yellow is the brainstem. The brainstem looks like what it suggests. It appears to be a stem from which the rest of the brain flowers, like a head of cauliflower. I want to show you a video where you actually can see this in terms of what it actually looks like.
When we look at the brain from below, the brainstem stands out clearly. You can see how it essentially connects the cerebellum with the cerebrum. The brainstem is also readily apparent if we look at a cross-section of the interior of the brain after it has been sliced down the middle. The brainstem encompasses the midbrain, the pons, and the medulla.
Okay. So the hindbrain includes the cerebellum and two structures found in the lower part of the brainstem, the medulla and the pons. Let's talk about each one of these to see what they do. Cerebellum, let's take a look at that.
The hindbrain consists of three structures. The cerebellum, seen here, a relatively large structure that constitutes about 10% of the brain's total volume. The pons, which is found near the top of the brainstem and appears to protrude from it. And the medulla, which is located at the base of the brainstem, just above the spinal cord.
So the cerebellum plays a role in balance and coordination of movement. The pons plays a role in the regulation of sleep and arousal. And the medulla that plays a role in essential functions such as breathing. So if the medulla got damaged, the result of that damage, unfortunately, would probably be death. Okay. So the cerebellum, which literally means little brain, is a relatively large and deeply folded structure located adjacent to the back surface of the brainstem. The cerebellum is critical to the coordination of movement and the sense of equilibrium, or physical balance. Damage to the cerebellum disrupts fine motor skills, such as those involved in writing or typing. The pons includes a bridge of fibers that connects the brainstem with the cerebellum. The pons also contain several clusters of cell bodies that contribute to the regulation of sleep and arousal. And then the medulla, which attaches to the spinal cord, has the charge of largely unconscious but essential functions, like I said, such as breathing and maintaining muscle tone and regulating circulation. Now let's take a look at the midbrain. The midbrain is the segment of the brainstem that lies between the hindbrain and the forebrain. The midbrain is concerned with certain sensory processes, such as locating where things are in space. The midbrain is the origin of an important system of dopamine-releasing axons. Among other things, this dopamine system is involved in the performance of voluntary movement. The abnormal movements that are associated with Parkinson's disease are due to the degeneration of neurons in this dopamine-releasing area. Running through the hindbrain and the midbrain is the reticular formation. Lying at the central core of the brainstem, the reticular formation contributes to the modulation of muscle reflexes, breathing, and perception of pain. It is best known, however, for its role in the regulation of sleep and wakefulness. Activity in the ascending fibers of the reticular formation are essential to maintaining an alert brain.